In this video, I'm going to talk about the data preparation and exploration of Starvo survey dataset. It will cover the following content. First, data preparation. I imported the CSV file and changed column names into more succinct names. For example, I changed the column "Do you consider yourself to be a fan of the Starvo film franchise" to Starvo fan. Then I checked the data types of each column. They are objects and flows. As answers of each survey questions are discrete and have limited number of possible values, they need to be changed to categorical data type. Then I checked the missing values in each column and the CSV file. There are 350 rows with most of movie-related values missing, and 140 rows with demographic values missing. These rows have very limited value and are removed. Although there are 16 rows with no demographic values, but have movie-related values, they only occupy less than 2% of the total data, so I presume drop them will not affect the whole distribution. Then I took a closer look at unique values in each column. I found and fixed the following issues. The Scene Starvo column has extra white spaces to be trimmed. The Starvo fan column has typo. From Scene Episode 1 to Scene Episode 6 columns, the answers are names of episodes or missing values. I assume that those who seen the episode will have the episode name in the answer, and missing value means have not seen. So I filled the missing values in these columns with no, and changed the episode names to yes. From episode 1 rank to episode 6 rank columns, I filled the missing ranks with 0. I converted the rank values to categorical data with order. Then I filled the missing values in other columns with no answer. Attitude to characters columns are converted to categorical data with order. Column Universe Fan has typo. Column Star Trek Fan has typo and lowercase strings. Column Gender has lowercase strings and typo. Column Age has impossible value 500. I made a sensible guess that the answer should be 50, so I replaced it to 45 to 60. It is also converted to categorical data with order. Columns Household Income and Education are converted to categorical data with order. To make string values case insensitive, all string values are converted to uppercase. After all these steps finished, I checked unique values in each column to make sure all typos, impossible values, and extra white spaces have been fixed. All missing values are replaced. Data types of all columns have been converted to categorical data. All the implementations succeed, and the data is ready for the next step. Second, data exploration. Let's have a look at how people rank episode 1 to 6. To have an overall ranking score of each episode, I calculated the average ranking score for each episode with the equation below. I assigned different weights to each rank. Rank 1 has the highest weight 6, by contrast rank 6 with 1 and rank 0 with 0. As can be seen in the bar chart, episode 5 had the highest average score 4.49. Episode 6 is the second favorable episode with average score 3.96, then followed by episode 4 which scored 3.74. Episode 3 is the least favorable episode, with average score 2.65. To have a more detailed analysis, I plotted bar charts of ranks for each episode. Regarding to the most popular episode 5, there are 35% people ranked 1 and 28% people ranked 2. Only 5% of people ranked 6. For the second favorable episode 6, although only 18% ranked 1, most people ranked 2 and 3, which occupied 28% and 26% respectively. Episode 4 is the most controversial episode. 25% of people ranked 1, while 19% people ranked 6. For episode 1, most people ranked 4, which occupied 28%, followed by 20% people ranked 6. For episode 2, 36% people ranked 5, while only 4% of people ranked 1. The least favorable is episode 3. Most people ranked 6 and 5, which occupied 26% and 24% respectively. By contrast, only 4% ranked 1 and 5% ranked 2 regarding to this episode. To explore the relationships between different columns, we need to have a hypothesis, then focus on these columns and examine these hypotheses through visualization. I examined 3 hypotheses. My first hypothesis is Star Trek fans are probably also Star Wars fans. Star Wars and Star Trek share many similarities. They both have their stories in the space. So I plotted a bar chart of these 2 columns. As can be seen, 89% of Star Trek fans are also Star Wars fans. My second hypothesis is most Star Wars fans choose Han shot first, while most non-fans don't know the question. The controversy over who shot first refers to a change in the 1997 special edition of Star Wars. Han shoots Greedo dead in the original version, while in later versions, Greedo attempts to fire at Han first. Many fans believe that Han shot first makes his later transition from anti-hero to hero more meaningful. As can be seen, 49% of fans chose Han shot first, while 28% fans chose Greedo shot first. 64% of non-fans don't understand the question, so the data proved this hypothesis. My third hypothesis is Star Wars fans rank higher on episode 4 as it is the first released episode. Episode 4 released in 1977. People have different opinions on this episode ranking. 29% of fans ranked first, and 21% of fans ranked second. On the other hand, 25% of non-fans ranked 6, and 24% of non-fans ranked 4. So this hypothesis is also proved by the data. Then I'm going to explore relationships between demography and attitudes. Firstly, let's check the distribution of each demographic column. The distributions of household income, education, and location are very uneven, and there are much less data from some categories. To avoid the biased analysis, I focused on exploring the relationships between gender, age, and their attitudes to Star Wars characters by plotting bar charts. For gender and attitude regarding to Darth Vader, I found that a large proportion of males, which occupies 43%, chose very favorably, and only 13% chose very unfavorably. On the other hand, lots of female has disagreements about Darth Vader. 30% of female chose very favorably, and 23% chose very unfavorably. By contrast, many males, which occupies 31%, chose very unfavorably to Jar Jar Binks, while much less females, which occupies 18%, chose very unfavorably. For age and attitude, younger people tend to like Boba Fett. There are 23% of people aged 18 to 29, and 24% of people aged 30 to 44 chose very favorably to Boba Fett, while only 8% of people aged 45 to 60 and 11% of people older than 60 have the same choice. By contrast, younger people tend to dislike Jar Jar Binks. There are 31% of people aged 18 to 29 and 36% of people aged 30 to 44 chose very unfavorably, while only 11% of people older than 60 chose the same answer. This is my data preparation and exploration on Star Wars datasets. Thanks for watching.